Okay, so I wrote an hour-long video. Not good. Took all the stuff that I thought were important, and hopefully I can make this a lot shorter. Okay, let's do a recap. Yeah. Let's do a recap. So, when dealing with a polynomial of power of 2, alright, always look at the back number and the middle number. Don't really have to worry about the front. So the back number. Alright, the back number you always look at to see what two numbers multiply to the back number and add up to the middle number, right? So what multiplies to 6? 1 and 6, 2 and 3, and that's it. Okay, what adds up to positive 5? Not 1 and 6, but 2 and 3, they add up to positive 5. And so you write it in this notation, x plus 2, x plus 3. And that's how you factor out a polynomial. You could have something like x squared minus x minus 6. Alright? Same things apply. What multiplies to negative 6 and adds up to negative 1? So you got, you could do variations of negative 6. So right here, you got 1 and negative 6. You got negative 1, 6. You got negative 2, 3. You got you got positive 2, negative 3. Those are the four combinations that multiply to negative 6. But which one adds up to negative 1? This one adds up to negative 5. This one adds up to 5. This one adds up to 1. This one adds up to negative 1, so it has to be this one. So, you write the same thing, x plus 2, x minus 3. That's how you'd factor something like that. Had x squared, let's say minus 25, right? And so, if we look back at the other one, it's x squared plus 5x plus 6. So the back number is this one, the middle one's that one. But which one's the back on this one and which one's the middle on this one? Well, the back number is always the one without the variable with it. Right, so this is just 6 by itself. The middle one is always the one with the variable to the power of 1, right? So ignore the front, right? So this x squared minus 25 is the same as saying x squared minus 0x, or plus 0, it doesn't really matter, minus 25. Right, because 0 times x is 0. And so we can rewrite this as this, and now you can do what multiplies to negative 25 adds up to 0. Well, you could write on the side if you need it. Multiples of negative 25 is 1 and negative 25. Negative 1, 25. 5 and negative 5. Which one adds up to 0? It would be 5 and negative 5. So that's what you write. X plus 5, x minus 5. That's how you do factoring of polynomials. Okay, let's go on to fractions and their thingy. When adding fractions, adding or subtracting, so I'm going to put plus or minus. When adding or subtracting fractions, the base of the fractions have to be the same, or they're also called the denominator. So the denominator of each fraction must be the same. So to do this, you have to multiply both fractions by a number to get them the same. So this one you have to multiply by 3 over 3, right? So you multiply this one by 3 over 3. This one you have to multiply by 2 over 2. And then this equals 3 over 6 plus or minus, because it doesn't matter, 2 over 6, right? Because 2 and 3, their lowest common factor that they share is 6. So then you have to multiply this side to get that 6, multiply this side to get that 6, and whatever you do to the bottom, you got to do to the top. That's how you get that. And then if it's like plus, now you have the same denominator, so it's going to be 5 over 6. That would be the answer. I do this just in case you do need it, but I'm going to kind of gloss over this because I didn't really see it in your homework. But if you do have it, send me a text so that I could go into more detail about it, but I'm just kind of speed running this right now. So I think, at least for your homework, you worry about multiplication and division for fractions, so I'll focus on that. Okay. For multiplication, it doesn't really matter. You just multiply the top and the bottom. So 1 times 1 is 1, 2 times 3, 6. That's all you have to do. Simple. For division, we call it, when dividing with fractions, you multiply by the reciprocal. What's the reciprocal? Well, the reciprocal is just the reverse of one of the fractions. So when division, you have two fractions, you have a division sign, you pick one of the flat fractions and you flip it, right? So 1/2 divided by 1/3. Usually you pick the second one, so let's pick 1/3. So you change this to 1/2 times 3 over 1, right? We flip the 3 and the 1, so now that becomes that. And then you change the division to a multiplication. Now it's the same thing. 1 times 3 is 3. 2 times 1 is 2. That's the answer, right? So when dealing with fractions and you have a division, you always flip one of them and then you change division to a multiplication symbol. Okay, now, so let's do just distributing. x1 plus 2, whatever. Technically, you could add these, so you could do 3 inside, but we're gonna forget that for now. Well, no, don't forget that. You know what? I'm changing this to a x. Okay, so x, 1 plus x. That's what we have. So when you're distributing, you're giving this x to each one, or you're multiplying this x for every term. So it's going to be, give it to here, it's going to be x, give it to this one, it's going to be x squared. Alright? So that's what distributing is. Factoring is essentially doing the opposite. You're breaking it down to its like easiest components. So if I wanted to factor this, I see this has an x, I see this has an x squared. X squared is the same as saying x times x, so this has an x, this has an x and an x. I could take out one x from both, which is what we do here. So, and then so the reverse would be this has an x, this has an x. I could factor out at least one x from here, so it'd be 1 plus x. Right? Same thing, I could distribute back and get the same thing here. Alright, so that would be distributing and factoring. Canceling out is what we're going to be doing, or factoring and canceling out is what we're going to be doing for this one. But the basics of it is x plus 3x over x. Okay. Okay. Technically, I could add these two together and get 4x in the top, but let's just focus on this for a second. So I have an x here, I have an x here, and I have an x here, right? Every single term on top is being multiplied by x. That means I could factor out an x. So let's do that. So that's going to become x 1 plus 3 over x. This x applies to each term. and this x on the bottom applies to everything on the bottom because it's the only thing there, right? So that means I could cancel this x with this x, right? Now you're probably wondering what happens to the x. Well, if you do, let's think about it like this, right? If I have 3 divided by 3, what's that? That's just 1. 1 times anything is itself. So if I had a similar thing, if I had x over x, anything I plug in for x is going to be, like, let's say x equals 5, right? 5 divided by 5, that's just 1. Right? If I had something complicated, like x plus 2 over x plus 2, well, guess what? They're the same thing, right? If anything I plug in for x, let's say 1, this is going to be 3 plus 3, or 3 over 3, that's 1. So canceling out is just, it turns into a 1. That's what canceling out is, right? So same thing here. Anything I put in for these x's, they just cancel each other out. So that's what happens to that. And so the final answer here would be 1 plus 3, which is 4. Okay, let's say I had something like this. 3x over x. Right? This x is being applied to every term on the top, right? 3 times x. This one's by itself at the bottom. That means I can cancel this x with this x. So bam, bam, this becomes 3 over 1, which is just 3. Okay? If I had something like 2 over 10, right? Now some people could see it, it's just 1/5, but if you want something to visualize it with, 2 over 10 is the same as saying 2 over 2 times 5, right? And so 2's on top, 2 on the bottom is being multiplied with everything on the bottom, so that means we cancel out this 2 with this 2, which is just 1 over 5, which is the same thing I said. Some people could just see it, it's just going to be 1/5, but that takes practice, and if you want to do it this way, it might be better to visualize it that way. If I had something that looked a little more complicated, like x over x cubed, right? What do I do here? Well, there's an x on top, and there's an x cubed on the bottom. X cubed, similar to what we're doing here, x cubed is the same thing as saying x times x times x. So, if you want to visualize it that way, it's going to be x times x times x. One of the x's cancel out, so you cross out that, so it becomes 1 over x times x, which is the same as saying 1 over x squared. Alright? Okay, let's say we have x squared plus x plus 1. We can't do anything else to this except for maybe factor it, but you can't add these together or subtract from each other unless you know what x is. This is because when adding or subtracting, you can't add when something doesn't have a variable when something has a variable without a variable, you can't add them together. If something is a higher variable than the other one, you can't add them together. So like x cubed plus x squared, you can't add them together because this is x cubed and this is x squared. And if this was x cubed, you can't add x cubed with x because they're two different, I guess, families. This is cubed, this is squared, this is x. And then this is 1, you can't add that with it. That being said, when multiplying, it doesn't matter. So if I had x times x, that's just x squared. If I had x squared times x, that's x cubed. And if I had x to the 25th times x squared, that's x to the 27th. If I had 3x squared times 4x to the 5th that's just 12 x to the 7th, right? So when multiplying with variables, you just add the exponent, or you add the exponents together, right? So x times x, this is technically x to the 1 and x to the 1, so 1 plus 1 is 2, x squared. X squared plus x, you add their exponents together, that's 2 plus 1 is 3. X to the 25th and x squared, you add the variable, or you add their exponents together, x to the 27, and then 3x squared times 4x to the 5th, you add their you multiply the coefficients, 12, and then add their exponents, which is 7. Let me preface this by saying you can add things together if they are in the same like family. So like x plus x, you can do that because they're the same one, which is 2x. If you had 3x squared minus x squared, they have the same variable with the same exponent, so you can do that, which is going to be 2x squared, right? So it's strict when you have to add or subtract, but when you're multiplying, you could mix and match and combine, right? Okay. Now, with that out of the way, I can actually go into the problems. So, this problem is, for each one, find the lowest form it could be, or like divide, I don't know. Just make it the simplest it could be. So, for this one, let's work at the top. What do these both share in common? It's 3x squared plus x cubed. So what do 3x squared and x cubed share in common? Well, they both have x's, right? So we can factor out 1x, but this is x squared and this is x cubed. So x squared is x times x cubed is x times x times x. So that means we could factor out 2 x's from both of them, right? So let's do that. So 2 x's is x times x, which is x squared. So I'm going to factor out an x squared. Alright? So if I distribute this out, x squared times 3 is 3x squared. X squared times x is x cubed. So it's the same thing. And look at that. I got x squared out. X squared on the bottom, I could factor it out, or I could cancel it out. And the only reason I could cancel out here, because this x squared applies to everything on top. If it didn't, then I can't cancel it out. But in this case it can, I can't, or in this case it does, so I can cancel this out. So the final answer here is 3 plus x, and that's it. For here, how can I simplify this further? Well, I have a 2 here and a 2 here, but I don't have a 2 here, right? So this is a 2x, this is a 1, so I can't add them together. So there's nothing I could do here. This is just a trick question. This is already at its simplest form. Because if I want to cancel out this 2 and 2, this has to be 2 as well, because the 2 has to apply to everything on top and bottom for it in order to cancel it out. Like this x here, there's an x here, there's an x here, there's an x here. Well, there's an x squared here, there's an x squared here, and there's an x squared here, right? Because this x cubed is similar to saying x squared times x. Now you could see that x squared applies to each thing everywhere. So x squared here, x squared here, x squared here, I can cancel them out. But here, this is 2, this is 1, this is 2. Can't work. That's already at its simplest. Let's go here. X plus 1 over x, right? Well, let's see. There's an x here. There's an x here. Well, no, there's not an x here. There's an x here. So this has an x. This doesn't have an x. This has an x. All right. Yeah, there's nothing I could do. This is also at its simplest. So these two are at its simplest form simply because the x's doesn't apply to each component on top. So those are common mistakes people make, is that they see a 2 here and a 2 here, and they're like, oh, we could cancel them out. But they have to understand that the 2 has to apply to everything on top and bottom. Same thing with here. They might see an x here and an x here, and they're like, oh, we could cancel out the x's. But the x has to apply to everything on top and bottom in order to work. It works here because x squared applies here, here, and here. We can cancel them out. Okay. Both of my wipes are dry. Alright. Let me hide that. I've already written that. So, let's say we have this one. 3x squared plus 3x plus 3 over 3. Right? So, what does the top have in common? Let's start with the top. Well, each one doesn't have an x. This has x squared. This one has x. This one doesn't have an x. So, we can't factor out an x. But each one does have a 3. So, we can factor out a 3. Which is here. So, we can take out a 3. So, now it becomes 3 parentheses x squared plus x plus 1. And since the 3 applies to everything on top and it applies to everything on the bottom, because the 3 is by itself at the bottom, we could cancel it out, and we're left with x squared plus x plus 1. And if they want you to go further, then you go further. But for what I'm doing right now, we could just stop right there. All right, next one. So you might look at that and be like, "What the hell?" However, let's just start at the top. You know, we'll work our way down. So the top, what does 8x cubed and 4x squared have in common? Well, they share x's, right? But they also share x squares, right? Because x cubed is the same as saying x squared times x. So they share an x squared. We can factor out x squared. But they also share 8 and 4, right? Because 8 is the same as saying 2 times 4. So let me rewrite this so that it's like a little clearer. This is the same as saying 2 times 4 times x squared. Again, towards the end, or if you're actually doing this on like a test, you probably shouldn't write it this way, and you should kind of just like maybe do it in your head. But right now, I'm just kind of like helping you visualize what's happening. And so this 2 times 4 times x squared, if you combine them together, because when you're multiplying it doesn't matter, you can combine everything, you get 8x cubed. This is the same as this. Or let me extend my finger out. There we go. That's the same as this. So now, I think you can see now. Both of these have a 4, so we can factor out a 4, and both of these have an x squared, so we can factor out an x squared. So let's do that. So we could rewrite this as 4x squared 2x plus 1 over 16x to the 4th minus 24x squared. Okay? I'm not going to do the same thing I did for the top, did for the bottom, but I will explain it, but I'm not going to write it, the same thing. Right? But let's work with the bottom now. So, let's start with the numbers. 16 and 24, they're both, or 8, you can multiply, or you could divide by 8 for both of them, right? So you could factor out an 8. Right, so if I divide by 8, you get 2 here. If you divide by 8, you get 3 here. So I could take out an 8. What about x to the fourth x squared. Well, x to the fourth is the same thing as saying x squared times x squared. So I could take out an x squared from here. And I could also take out an x squared from here. So let's do that. So to recap, I'm taking out an 8x squared from both of them, because that's what you can do that. So I can rewrite this as 4x squared 2x plus 1 over 8x squared 2x squared minus 3, right? Because 8x squared times 2x squared is 16x to the fourth. 8x squared times negative 3 is negative 24x squared. So that checks out, and if you do that, it checks out. Well, look at that. X squared applies to each one of them for both top and bottom, so you cancel that out immediately. And then the same thing we did earlier, 4 over 8. 8 is the same thing as saying 2 times 4, so the 4 cancels. So you can rewrite this as, You can rewrite this as 2x plus 1 over 2x squared minus 3, right? Because this 8 is the same thing as 2 times 4, and this 4 applies to everything at the bottom, and there's a 4 apply to everything at the top. So you can cancel out the 4's, and you're just left with this 2, which is right here. Right? And that would be the final answer, because you can't really do anything else with it. 2 only applies to this one and not that one, so you can't cancel that out. X only applies to here, not here, so you can't cancel out that. And then also X doesn't apply to this one either, so you can't cancel it. So this is the furthest you could go with that. This would be like kind of a challenge problem. Negative 10x to the 25. Okay, so 5x to the 30, negative 10x to the 25. So let's start with the numbers on top and bottom, right? I mean, you could probably see it. 5 divided by 10 is 1/2, but, you know, we're going to visualize it. So 5, right, that's on top. 10 is the same thing as saying 2 times 5. So, I mean, let's write that. Negative 2 times 5, x to the 25, right? 5 applies to everything on top. This 5 multiplies with everything on the bottom. You cancel it out. So now we're left with x to the 30 over negative 2x to the 25th. Right? Now remember, when multiplying variables, they add their exponent, right? So x to the 30 is the same way as saying x to the 5th times x to the 25th. Right? Because if I multiply these two together, you add their exponent, and that becomes x to the 30. Well, guess what? Now I have an x to the 25th multiplying with everything, x to the 25th on the bottom multiplying with everything. I cancel it out. So now I'm left with x to the 5th over negative 2, which on a multiple choice they might write it as negative 1/2 times x to the 5th. These are both the same. That's the final answer. Again, it's another challenge, kind of challenge one. So, I mean, let's start with the bottom then, because it's a little bigger, so let's start with it. Alright, let's start with the numbers specifically. What do 8 and 64 have in common? Well, 8 squared is 64, so that means we can factor out an 8 from here and here. Alright, so then, okay, now let's go with the variables. This is x to the 24, and this is x to the 28. Well, we know x to the 28 can be rewritten as x to the 24 times x to the 4th, right? So we could do that. for this one, I'm just going to factor out the 8 already. So, I'm going to factor out a negative 8. I'm going to do that. Just to make it look nicer. You don't have to do it, but I think it looks nicer, so. Right? So, 72x to 28, same thing. If I distribute this negative 8, it becomes negative 8x to the 24 minus 64x to the 24 times x fourth, right? Because x to the 4 times x to the 24th is x to the 28th, which is right here. Now from here, you can see there's an x24 here and here, so you're able to factor out because it applies to both sides. Or x to the 24 applies to everything in the equation, so you're able to factor it out as well. So I'm actually just going to erase it because it's easier. Right? So now it's negative 8 x to the 24 parentheses 1 plus 8x to the 4th. And if you want to distribute that and check it, you get this. Okay. Now, we start canceling stuff in top and bottom. So let's start with the numbers. What do 72 and 8 have in common? Alright, well, 9 times 8 is 72, right? So you could rewrite 72 as 9 times 8. We have 8 here and 8 here. This 8 applies to everything on the bottom. This 8 applies to everything on top, so you're able to cancel them. Alright, so then we can rewrite that as 9x to the 28 negative x to the 24 1 plus 8x to the 4. Alright. And then same thing we did here for the 28. There's an x24 here. We know x to the 28 is x24, or x to the 24th times x to the 4th. Right? So now this applies to everything on the bottom. This applies to everything on top. Cancel, cancel. So now we can rewrite it as 9x to the 4th over negative 1 plus right. Now this would be the final answer. Again, you don't want to fall into the trap of saying, oh, there's an x to the 4th here, there's an x to the 4th here. Shouldn't we be able to cancel them? No, because this x to the 4th here doesn't apply to everything at the bottom. It's not multiplying with everything at the bottom. If this was x to the 4th plus 8x to the 4th, then you could factor that out and then cancel it with this on top. But since because x to the 4th doesn't apply to everything at the bottom, you can't cancel it with top and bottom. Alright, let's do one more, and then I'll get to your homework problem, and then I'll edit this video and I'll call it. You might want to start with you can either do the division thing, right? When dividing with fractions, you gotta flip one of them, or we could just focus on this side first, and we could try to maybe factoring that out. So we'll just do this one. We'll start with this right now. So how can we rewrite this? What multiplies to positive 36 and adds up to negative 12? Well, we got, I could write it down right here for a second. 36. We got 1 and 36. Negative 1, negative 36. We got, oh, there's a lot actually, hold on. 2 and 18. Negative 2, negative 18. You got 3 and 12. Okay, I shouldn't have done this one. There's a bit. But You got -3, -12. You got 4 and 9. -4, -9. And you got 6 and 6, -6, -6. Right? So these are all the multiples of 36. And then, so that's what multiplies to 36. But now what adds up to this -12? That can't, 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 that can't. Oh, look at that. -6, -6. That -6 times -6 is 36. -6 plus -6 is -12. So this is our factored form. So, now it's wet, damn it. Okay. So, it's still wet. We could rewrite this as x minus 6 over x minus 6 divided by x minus 6 over 3x squared. Okay. I mean, you could. It's still gonna happen, but there's an x minus 6 applying to the top everywhere here. There's x minus 6 on the bottom everywhere here. We could cancel it out, but let's focus on combining them now, right? We'll touch on that in a second. So when dividing with fractions, you multiply by the reciprocal, or you just flip it. So we could rewrite this as x minus 6 over x minus 6 times 3x squared x minus 6. Alright, now when multiplying, you just slam them together. That's pretty much it. So now you can rewrite this as 3x squared x minus 6 x minus 6 x minus 6 x minus 6. Right? Well, now look at that. You have an x minus 6 being applied to everything here, x minus 6 being applied to everything here. Cancel this one with this one. Okay. Well, we have an x minus 6 being applied to everything with this, and the only thing left at the bottom is x minus 6, so that applies to everything, so we can cancel this one with this one. Now we're just left with 3x squared. So the final answer here is 3x squared over 1, which is just 3x squared. Alright, so ax squared, 20x to the 9. So we kind of did this already, but we do another one like this one. So let's start with the numbers. What do 8 and 20 have in common? They're both even. There's another one you could do, but I think for breaking it down, we should just do that. They're both even, right? So this 8 is the same thing as saying 2 times 4. So 2 times 4, x squared. This 20 here is the same thing as saying 2 times 10. 2 times 10, x to the 9. There's a 2 being applied to everything on top. There's a 2 being applied to everything on the bottom. We can cancel it out. Now we're left with 4x squared over 10x to the 9th. We could still break down the numbers more. They're both even again, so we could go one step further. 4 is the same thing as saying 2 times 2. 10 is the same thing as saying 2 times 5. 2's cancel out, so you're left with 2x squared over 5x to the 9th, right? You could jump from here to here if you know that 8 is the same thing as saying 2 times 4, and 20 is the same thing as 5 times 4. Right? Because now 4 cancel out, you're left with 2 over 5. So you can skip these 2 steps if you know that. But if you don't know that, you could just slowly go down. It's fine. All right. So now let's work with the variables. So we have an x squared on top, and we have an x to the 9th on the bottom. So we can break it down, however, because x to the 9th is the same thing as saying x squared times x to the 7th, right? Because you multiply these together, you add their exponents. So we got 2x squared over 5x to the 7th times x squared. We have an x squared on everything on top. We have an x squared being multiplied with everything at the bottom. Cancel, cancel. Now the final answer is going to be 2 over 5x to the 7th. That's the final answer.